Okay, today we are just going to look at reviewing the area formulas that we've been talking about. And then the last one on this paper is what we're going to be getting into recently here in our next few lessons when we talk about circles. But I just wanted to put all your area formulas on one page so you can easily understand what it looks like as well as with the picture. Okay, so with a parallelogram or a rectangle, they have the same formula. Okay, as we've talked about in our previous lesson, a parallelogram is just like a tilted rectangle. Instead of having 4 right angles like a rectangle does, but it still does have a base and height. So parallelogram is like a rectangle. Another way you can think about it is you could take this part of the triangle, if you cut that as a triangle, and move that over here. It actually does make one rectangle. So that's why we're going to do base times height for both the parallelogram and the rectangle. So if we said the base, we're going to use a pink to highlight for that, and blue for the height, just to kind of color code it to help us out. So that way in every parallelogram, you're going to have a base and its height. Okay, so we could say this base or this top one, it doesn't really matter, but in a parallelogram, this side length is parallel and congruent to that side length, and this side length is parallel and congruent to this side length. That's why we say a parallelogram only has one base. Okay, important note that I'm going to put on here as well. Remember that the base and height always form a right angle. Your height is never slanted. So something we really want to make sure that you remember, because if they give you one of these side lengths, you don't want to use that for your height. That would be a trick answer if you did this base times that height. Okay? So then we can take a triangle and we have a different formula, half base times height, or you could actually rewrite this. When I multiply by 1/2, that's the same thing as dividing by 2. So you won't see this on your math chart, but if you want to rewrite that and start memorizing it, that will help you out. Okay? So same thing as the parallelogram, your base and your height are going to form a right angle. Okay? So your base and your height form a right angle. So you need to first identify the shape that you're working with, then color code those base and height or label them on your paper so you know what numbers you're going to be substituting here, okay? So base and height. Now it's important to note on this right triangle, you could technically turn this paper and this be your base and this be your height, but either way when I multiply those two numbers I'm going to get the same product, okay? Over here we had to only have this one as the base because it's forming that right angle with the height. Remember, your height is never going to be slanted, so those slanted numbers we're not going to use for the base or the height in that triangle. Okay? Remember, multiplying by 1/2 is the same thing as dividing by 2. If you are using this formula, order of operations, multiply the base and height first, then multiply by 1/2, but making sure everything's a fraction, like we've talked about in previous lessons as well. Okay? And friendly reminder, the reason why this works out, why this formula is that, if I had a square, a rectangle, or a parallelogram and I cut it in half, I actually have 2 triangles. So if I want the area of this, I could take this base times its height, but that would be the area of the whole square or rectangle or parallelogram or whatever it is, one of those 3. But if I only want half of it, that's why we're dividing by half. So if you imagine cutting this like that into 2 congruent triangles, if you want only the area of this part, well, the whole part is base times height, but if we only want that part, it's divide by 2. Okay, so that's something that we need you to think about. All right, let's look at trapezoid. So this one looks a little intense, but in our previous video, I've explained why that was the formula. And in this one, it's a little bit different because we don't have just one base, we have 2. And in case you forgot why that was, the bases are the parallel lines, And this side measurement is not the same as this side measurement. And this parallel line is not the same as this parallel line. So if we were to double this trapezoid and turn this one around and push it together, we can make a rectangle or a parallelogram. The same thing with this one. We could double it, turn it around, push them together like we did in the previous video, and see that they're going to make a parallelogram or a rectangle. And so that's why we have to add those bases together to make the total of this base. Okay? And then your height still forms your right angle. So sometimes on the trapezoid, the height's going to be on the outside. Sometimes it's going to be in the inside, just like this triangle. Just depends on where the right angle is. Okay, so your height always forms a right angle with your base. And then we just want to make an important note right here. Your bases are always parallel with one another, with each other. Okay? So this is why we need to get you guys in the habit of making sure you're labeling what these numbers represent. So in this case, if you have these outside numbers over here, this one you would need, but this one you would not. You would only need those outside numbers if we need the perimeter of the shape where we're adding it up. Remember, area is everything that fills up on the inside. Okay? Now, circle we're going to get to in the next lesson, next couple lessons, but we're going to go ahead and review it just real quick. And just in case you guys forgot, remember your radius goes from the center to the edge. So from the center to the edge of the circle. And circumference we talked about was like the perimeter of the circle, so that's the outside. And that formula is different. Your area, which we're going to get to here in a little while, next couple lessons, remember area is everything on the inside. So if we want to see how much space that this circle would fill up, we're going to use this formula pi r squared. And in case you forgot, your exponent means repeated multiplication of the base. So notice this 2 is only by the r. So we're only taking r to the second power. So that means my radius times my radius. Pi was not going to be taken to the second power because we don't have an exponent right next to it. Okay, so again, we're going to see this here in the next couple lessons. So it would be helpful if you wrote pi times radius, so that way you can fill in the blank for it, okay? Again, coming up in the next few lessons. Now remember, your exponent does not mean radius times 2. If you actually did that and said pi times radius times 2, that's actually going to give you your circumference. So we really need you to be careful on that. And the next thing I just want to tell you before we sign off and you do some practice problems on your own, well, let's say that they actually gave you the diameter. So what if I said this was my diameter? And use the purple for that. Well, remember, from the center to the edge is your radius. From the center to the edge is another radius. So we said for every 2 radius, there was 1 diameter. So if we said radius and diameter, remember we could say radius times 2 to get to my diameter. So if they give you a picture with the diameter, we're going to go backwards and say divide by 2. Okay? And again, this is going to have some practice problems in the next few lessons, but just wanted to kind of give you a preview right now. So we're just going to make a note. If you are given the diameter, find the radius before you can find the area. Okay, this is a really important note to know because for our area of a circle, we do not have a formula dealing with the diameter. So if they give you the diameter of a circle, divide it by 2 to get your radius and then substitute your numbers in. Okay? Alright, so this is just a review of how these formulas work, and as always, make sure you reach out to your teachers if you do need help as you're working on your independent practice, and good luck.